Alright, let's jump to this one. Here's mercury fluorine, so it's going to be mercury fluoride. And over here, mercury fluoride. Now I can't just say mercury fluoride, because they're two different formulas. So I have to figure out what charge mercury has so I can put it in parentheses here. So let's work backwards. And let's start with the easy one. I'm purposely going to start with this one right here. This to me looks like immediately, it's easy to recognize, a 1-to-1 ratio. So there's going to be 1 mercury and 1 fluorine. The only catch is I need to know what the charges of each are. So here's fluorine. Fluorine's a representative element. It always makes a -1 charge. Never, ever, ever is going to change. So fluorine's -1. Now, if this is a 1-to-1 ratio and fluorine's a -1, what do you think mercury is going to be? +1. So I know that this mercury is going to be a mercury 1 fluorine. It's going to make a +1 charge. Now, what about this one here? Here's fluorine with a -1, because it's always going to make a -1. But there's 2 fluorines. So let's picture, you don't have to draw this out, but let's picture a -1 and then another -1. They're getting, as a group, 2 electrons from the mercury. Mercury is going to give this one 1 electron and this one 1 electron, which is why it's hooking up on a 1-to-2 ratio. So this mercury is giving away 2 electrons. So there's going to be a +2 charge. The other way I could have done that was uncrisscrossed. So if I uncrisscross, I could have written HgF2, take the 2 here, put it up. Remember, it's going to be positive because it's a cation. Cations always come first. Take the imaginary 1, put it over here. The catch is, before you decide, hey, this is wonderful, I automatically know what the charge is on mercury, you have to check to make sure that your non-metal makes sense. You ask yourself, does fluorine make a -1 charge? And the answer is yes. If that makes sense, then this is going to be perfect. If it doesn't make sense, then you've got some more thinking to do. Let me show you how that works. Let's do 13 and 14. Here's 13, cobalt, CO is cobalt, hooking up with oxygen, so it's oxide. Here's another cobalt hooking up with oxygen. I can't just call the 2 of them cobalt oxide because they're 2 different ratios. So let's start with the top one, the easy one here. Here's COO. I'm going to write it up here. This is a 1-to-1 ratio. So if I was just to say that this is a 1 and this is a 1, because these guys are imaginary 1s, then this would be wrong. That's not a +1, and oxygen is not a -1. I don't know necessarily that that's wrong right off the bat, but I do know that that is absolutely positively wrong. Before you decide that this is wonderful, that this is correct, you have to check to make sure that this one makes sense. This one does not make sense. Oxygen's not a -1, it's a -2. In order to get from the -1 to the -2, I double it. So whatever I do to get the oxygen straight, I have to do to the cobalt. So I'm going to double the cobalt, and now I'm all set. +2, -2, there's my 1-to-1 ratio. So I know that cobalt is a +2, oxygen's always a -2. So I know that cobalt in this case is a +2 charge. Now let's look at the next one, COO2. CO and then O2. Take the 2, put it up there. Take the imaginary 1, put it up there. Again, before you decide that this is wonderful, check, does this make sense? Oxygen does not make a -1 charge. That is incorrect. It makes a -2 charge. Again, I have to double it. So whatever I do here, I also have to do here. That 2 is going to become a 4. So now it's going to be CO +4, oxygen oxygen -2. And then if I crisscross, I would end up with a CO2O4, which can basically be reduced. These always have to be reduced to the lowest numbers. So it's a COO4, O2 rather. COO2. Because the CO with the 1, imaginary, and then the O2. And that's what I have here. So I know that cobalt is a +4, oxygen's always a -2. So this is going to be a 4, which is why I told you how to write all these Roman numerals. Okay, so give the rest a shot. The next section we're going to talk about are polyatomics. A little bit more challenging than what we've been doing, but I would expect that all of this stuff from here, or from the beginning to up to here, you've done already, or at least you've been exposed to. Some of you, I'm sure, are flying through this and are bored. That's a good thing. Some of you have some work to do. If you don't understand certain sections, jot down specific questions and come into class prepared, and we'll obviously spend some time going over this. But I assume that everyone's going to come in with some general knowledge and pick this up in a day or so, and then we're going to be able to move on to the polyatomics and make this a little more challenging. All right, good luck.